Hello students, good evening. Welcome to another class of Vedantu, Karnataka. This is Catherine, your physics master teacher. Quickly, can you let me know if I'm live? Yeah, you can't let me know if I'm not live, but can you let me know if I'm visible or audible? Let me also check. Yeah, I am visible. Hello students. Yeah, so the class has started a little late. There was a small overlap. Yeah. Okay. How are you all doing? So this is first PU class, okay? So all those who are new, yesterday I was doing second PU, today I'm doing first PU. You can just look at the thumbnail. It will be clearly written first PU. Okay? So we have been looking at motion in a straight line. So I've already done part 1. Today I'm going to do part 2. Hi Luna, Rakshita. Hi Mahesha. Hello, hello. How are you all doing? Are you all fine? Kannada bolo. Chennagide all of you. Ananda got BMS seat because of you, ma'am. Oh, congratulations, Ananda. I'm very happy to hear that. Okay. Very happy, very happy. Please let us know all your achievements in the comments, okay? So, after so many years, also we can go check the comments and see, okay, this student got this because of us. It really feels good. Yes? I'm good, Attar. How are you? Yeah, so let's not waste time. Let's start our class because we already lost some time. So, let's start. So, as I said, motion in a straight line. So, under the last class, I had seen a comment of one student who had a doubt on example 5. So, if you're there in the live chat, you can just type in and let me know. I will explain that. Otherwise, then there's no point, right? Yeah. Hi, Samarth. Hello. So last class, what we were doing is we looked at acceleration, we looked at velocity and all that. Today, we are going to start with types of motion. Okay, we'll also be looking at equations of kinematics, we'll be looking at graphs, all of that. Yes? Yes. So let's start. Are you all ready? If you're all ready, quickly put some fire emojis in the chat. Quickly, quickly. Let's have some fire in the chat. Yes, yes, yes. Okay, let's start. So there are mainly two types of motion, uniform motion and non-uniform motion. What is uniform motion? Uniform motion is when an object covers equal distances in equal intervals of time. For example, I go from A to B in 2 seconds. Okay, let's say this is 5 meters. And then you go from B to C again in 5 meters, 2 seconds. So I'm covering 5 meters each in every 2 seconds. So this kind of motion is called uniform motion. Let's say I reach D in another 2 seconds. This is also 5 meters. So when I'm covering equal distance in equal interval of time, that kind of motion is called uniform motion. Okay? Hi Prabhavati. Prabhavati asked me if I like Rajnikant. I like Rajnikant. Okay. Hi Penchalaya, I don't know if I'm pronouncing your name right. Penchalai. Hi Uday. Hello everybody. Okay, welcome to the class. Thank you so much for joining. Okay, let's concentrate on class. Okay, Prabhavati said I have Rajnikant hairstyle. Or I should have Rajnikant hairstyle, something like that. Okay. So the first kind of motion is called uniform motion where the body covers equal distances in equal intervals of time. Okay. So what is the formula for speed? I've already taught you this. Speed is what? Speed is distance divided by time. So here from A to B, if you find out speed, it is 5 by 2. From B to C also it's 5 by 2. From C to D also it's 5 by 2. Yes. So the speed is the same throughout. So that means that in uniform motion, speed remains constant. Okay. So there is no change in speed. The whatever it is, it covers equal distance in equal intervals of time. Yes. Understood? Now the second kind of motion is non-uniform motion. So what will non-uniform motion be? Again, let's say there's A, there's B, there's C, and there's D. Okay? So A to B is 5 meters, and let's say B to C is 10 meters, and C to D is 12 meters. Okay, so A to B is covered in 2 seconds, B to C is also covered in 2 seconds, C to D is also covered in, let me put centimeters so it is more realistic, right? You can't cover 12 meters in 2 seconds. Okay, I'll put centimeters. So what it means that from A to B, an object moves 5 centimeters in 2 seconds. And then it slows down. It can only move 10 centimeters in 2 seconds. Then it slows even more. 12 centimeter it moves in 2 seconds. So even though it takes the same amount of time, but it covers unequal distances. Okay? So non-uniform motion is when speed continuously changes and the body covers unequal distances in equal intervals of time. Yes? So it's like a car in city traffic. So if you're from Bangalore, you know Bangalore traffic. Okay? So it's like a car in Bangalore traffic. You can't go with the same speed throughout. You can't cover the same distance in equal intervals of time. Your Google map might show you will reach this place in 10 minutes. But if you get a block, you will reach the place sometimes in half an hour, sometimes in 1 hour. Okay? It all depends. So you can't cover equal distance in equal intervals of time because of the traffic. But uniform motion is like you go on a highway. Highway, there are very little cars, so you can cover equal distance in equal interval of time. Yes? Yes, yes, yes. Ma'am, can you please explain uniform motion? Srivani, see, what I just explained now is non-uniform motion. What is uniform motion? Uniform motion is when, see, imagine you are driving your car, okay? You go from A to B and you have to cover a distance of 5 meters, okay? To go from A to B, you take 2 minutes. Now you reached B. Let's say B is your friend's house, okay? Let's say that you have 5 friends' house. They are at equal distances. Your house to your friend's house is 5 meters away. Now your friend's house to another friend's house is again 5 meters away. Now to another friend's house is again 5 meters away. So you have 4 friends living 5 meters away. You drive from A to B, you take 2 minutes. Now from B again you drive to C, you again take 2 minutes. From C to D also you take 2 minutes. Now this could also be a very straight road, okay? A straight highway road where you are driving or you are running or you're walking, whatever motion, any motion, you might be cycling, anything, but you cover the same distance in the same amount of time. Just like after every 5 minutes, you take only 2 seconds. So in the next 5 minutes, again you take 2 seconds. Now, if the next 5 meters, if you take 4 seconds, then this part will become non-uniform. Did you understand that? So uniform motion is when you travel the same distance in the same amount of time. Okay? It's called consistency. Like if you're running for a race, from the starting of the race till the end of the race, if you have the same speed and you cover the same distance in the same amount of time, then you have uniform motion. But imagine you're going for a marathon. Initially, you'll be very fast. But after some time, you'll start walking. After some time, you'll start crawling. After some time, you'll sit there. That is non-uniform motion. Okay? Is it clear, Srivani? Can you let me know in the chat, Srivani, if it's clear to you? Okay, so that is uniform motion and non-uniform motion. Now we are going to look at the different equations of motion. Okay? Now before we look at the equations of motion, we need to consider 2 cases. Okay? First case is when acceleration is constant. Okay? First case is when acceleration is constant. Now some of you might be wondering what is acceleration. To neatly understand the whole concept of acceleration, you have to watch part 1. Okay, but I'm not, bribing you for, not bribing, what do I say? This is not a marketing strategy for you to go watch video 1, okay? There I have explained acceleration properly. But here I'll explain once again. Acceleration is basically how your body changes speed with respect to time. Okay. So when you're driving your car, if you're going with the same speed, it's just same speed. But if you press the accelerator, it increases the speed. So the amount of increase in speed or decrease in speed with respect to time is called acceleration. Okay. Now acceleration is also uniform and non-uniform. This I want you to go watch that video. Okay, because I have a lot to cover today. So if acceleration is constant, that means from A to B and B to C and C to D, the same acceleration is there, then it's called uniform acceleration. Then these equations of motions can be used. Okay, which are the three equations of motion? V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS, Sn plus n is equal to U plus half A 2n minus 1. Okay? Is this clear? These equations of motion are valid only when acceleration is a constant or acceleration is uniform. Okay? Yes. Now, if acceleration is not a constant, okay? So, if acceleration is not equal to a constant, or if it's, that if acceleration is not equal to constant, it means it's non-uniform. If it's a constant, it is a single value. Let's say acceleration is 10, then it is constant, it is uniform. If acceleration is say initially 3, then 5, then 8, then 15, then it's called non-uniform acceleration. So if acceleration is not a constant, then we have to use differentiation. Okay? Differentiation. So you take velocity as the differential of distance, acceleration as the differential of velocity. Acceleration can also be written as v into dv by ds. So this part right now you don't need. You only need to know about the part where acceleration is constant. Okay. So for your PU point of view, you only need acceleration is constant part, which are the equations of motion. So we will be looking at those terms. Okay. Yes. So now what we are going to do is we are going to derive these equations of motion. We are going to derive all these 4 equations of motion in 3 different ways. So first we will derive the equation of motion by a general method. Okay. So equations of motion derived using a general method. Okay. This is not the graphical method. This is just a general method. Are you all ready to derive these in a general method? Let me just a second. Okay. Not able to see the chat properly. One second. I'll just put it like this. Okay, now I can see the chat. Okay, yeah, perfect. Okay, so the equations of motion, derivation using general method. We will be deriving it in 3 different ways. First one is the derivation using general method. Now, first thing, what is the first equation of motion? V is equal to U plus AT. This is the first equation of motion. I'm sure all of you have seen this, at least in class when your teacher did hours of derivation. You've actually seen this, right? You might not have understood, but you've seen it. You obviously would have understood also because you have good teachers. But in case you were sleeping that day, I've got you covered. So V is equal to U plus AT. What is V? What is V? V is the final velocity. Very good. Good. What is U? Yes, U is the initial velocity. You're all very smart students. U is the initial velocity. Now what is A? A is acceleration. Hi Ramesh, welcome to the class. A is acceleration and obviously T is time. Alright, now let us derive this formula. So how do we start? We start by using the definition of acceleration. Yes, Rivani, U is initial velocity. Very good. Okay. So we start by using the definition of acceleration. The definition of acceleration. Okay. So what is the definition of acceleration? Acceleration is change in velocity by time. So acceleration is change in velocity divided by time. Acceleration is change in velocity divided by time. Now what is change in velocity? Delta V, the whole divided by delta T. Now what is delta V? Final velocity minus initial velocity. Delta T is the change in time. I will just put it as T. So now what you get? You get A is equal to V minus U by T. So from this I cross multiply. So AT is equal to V minus U. From this I take U to the other side. So it's minus U. So when minus U goes to the other side, what does it become? It becomes plus U is equal to V. Understood? Minus U going to the other side becomes plus U. So V is equal to U plus AT. Yes. So that is our equation of motion. Okay. Draw shapes. Okay, I should draw that here. Is this clear to all of you? Yes. Can you let me know in the chat if this is clear? So this is the derivation of the first equation of kinematics by general method. Okay? Yes. It's Chetan. You can call Sharmila. Okay? You don't have to call her dear. Yeah. No, so much of concern. You can call me. Okay? Okay. Let's move on. Just show it to you. If you want to take a screenshot, you will have my head also. Next, second equation of motion. So second equation of motion again by general method. Okay. So let's use general method and derive the second equation of motion. So second equation of motion is S is equal to ut plus half at square, where S stands for displacement. Students, please don't get confused. S is not speed. Okay. I've seen people people misunderstand S as speed. Okay. But S is not speed. S is displacement. Okay. U is initial velocity, T is time, A is acceleration. All that is the same. So let's do it. So what we will do, we will start by using the formula, general formula. So all general methods use general formula. So since S is displacement, let's start by displacement itself. So let's start by the formula. Displacement. Displacement is equal to velocity into time. Okay. So see, velocity is displacement by time. So displacement is velocity, which is the average velocity divided by time. S can also be written as X. Yes, in some textbooks it is written as X. But in your NCRT, they use the alphabet S. So I would suggest all of you to use the alphabet S itself. Okay. Okay, Srivani. Srivani, I will start motion of the plane next week. Tuesday or Wednesday, I will start that chapter. Okay. By tomorrow, we will finish this chapter and then we'll start it next week. Displacement is V average into time. So let's write down displacement is S. What is V average? V average is average velocity. How do I find average velocity? Initial velocity plus final velocity by 2. Yes. Average, what is average? You just add the velocities divided by 2. This is average. Into time is t. Now what I will do, I will take the first equation of motion. Okay. From the first equation of motion. From the first equation of motion, what will I write? What is the first equation of motion? S is equal to U, I put it as it is. Now, instead of V, I will substitute the first equation of motion. What is the first equation of motion? V is equal to U plus AT. So, instead of V, I will write U plus AT. The whole divided by 2 into T. Okay, what did I do? I only substituted V as U plus AT. Okay, yeah. Now I will open the brackets. So this becomes S is equal to 2U plus AT by 2 into T. Now this will be S is equal to 2U by 2. I am just splitting the terms. Plus AT by 2. How did I do that? See, A plus B by 2 can be written as A by 2 plus B by 2. Same thing I've just done. Okay. So let me erase that. Yeah. S is equal to 2U by 2 plus AT by 2 into T. Now what is the next step? Cutting 2 and 2. So S is equal to U plus AT by 2 into T. Now S is equal to UT plus half AT into T is AT square. I have UT plus half AT square. Superb. That is the second equation of motion. Yes, is this clear to all of you? Can you let me know in the chats if this derivation is clear? If you have any doubts, you can ask me now. Okay. So that is why students, I always tell you to attend live classes. Because you can ask doubts then and there. If you put a doubt in the comment, I usually reply, but sometimes, I can't type out the whole thing in class. So I'll ask you to join the next class. Yeah, I hope this is clear. So this is all general method. Okay, now let's derive the next one. V square is equal to U square plus 2AS. So here I'm not going to write down. What is V? Final velocity. What is U? Initial velocity. A is acceleration. S is displacement. So let's do it. So we will start from first equation of motion. Okay. So from the first equation of motion. So from the first equation of motion, we get V is equal to U plus AT. Yes. V is equal to U plus AT. Now, on squaring both sides, okay, I'm going to square both the sides. So what happens? V square is equal to U plus AT, the whole square. Okay. So V square is equal to, what is A plus B the whole square? A square plus B square plus 2AB. So it will be U square plus A square T square plus 2A is U, B is AT. Okay, I've just opened the bracket. Now what I'm going to do is, I'm going to multiply and divide this term by 2. Okay, so I'm going to multiply and divide this term by 2. Is that clear? Can you see that? Okay. 2 by 2. Okay. Multiply and divide by 2. Okay. Now let's do it. So now, why did I do it? It's just because I wanted to take 280 outside. Okay, that's all. That's the only reason. So is equal to u square plus. I can take 2 and a outside. What remains? Here what remains? A t square by 2 plus u t. These are the terms that remain. So this I will write it as v square is equal to u square plus 2a ut plus at square by 2. Okay? I just changed the order. Okay? Simply for easier calculation. Now, next part is from second equation of motion. What is the second equation of motion? S is equal to ut plus half at square. So here, what is inside this bracket? Isn't this the same as S? So, from this, can't I write from second equation of motion, from second equation of motion, can't I write this formula to be v square is equal to u square plus 2a? What is the bracket? The bracket is displacement. Ut plus half at square is displacement. Okay. So now I have my next equation of motion, which is my third equation of motion. Okay. Yes. This section will end, today's class will end like, I don't know, maybe 1 hour. But I will take one more class and then this whole section. Motion in a straight line will end. Maybe tomorrow. Tomorrow, I think. Yes, tomorrow. Okay, so tomorrow I'll be finishing this chapter. Is this clear? Oh my god. Hi, Kavya. I know, I remember you, Kavya. But then when you put the name Ramesh, initially I don't, it doesn't strike me. But now I know. Yeah. Is this clear? Clear? Okay, it's clear to Kavya. What about the others? Put some fire emojis in the chat if this is clear to you. Quickly, quickly. Okay. Now there's one more equation of motion which is to tell us the distance traveled in nth seconds. Okay. So this is to tell us the distance traveled in nth second. So if this is the starting point, okay, and then I travel all the way till A and then B. Okay, A, B, all that is fine. So initially when time is 0, this is when time is n minus 1. This is when time is equal to n. Okay, time is 0, time is equal to n minus 1, time is equal to n. Now, this part is Sn minus 1 and this whole thing I will label it as Sn. Okay, so this whole thing, yeah. Now, thank you so much, Ashwin. Ashwin says I'm a really good teacher. So the only thing that I want from all of you is share this video to all your friends. Okay, please share it to all possible first PU or first CBSE groups so we reach students. Some students, they're all, paying lots and lots for tuitions and they don't understand. So you get it for free here. Okay. So all of you give me like, share and subscribe. I want you all to subscribe to the channel as well. Thank you so much, Ashwin. It really means a lot. Shark Gaming. Yeah. Hi, Shark Gaming, my old student. Okay. So now we're going to derive the fourth equation of motion, which is to find out the distance traveled in nth second. Okay. So how do I do that? So I'm going to find out the distance traveled from A to B. Okay. So I'm going to find out the distance traveled from A to B and I reach B at n seconds. So I start at 0 seconds. So I reach A at some n minus 1 second and I reach B at n seconds. Okay. So let's start it. So distance traveled in the nth second. Okay. Distance traveled in the nth second is equal to AB. Okay. So AB is the distance traveled in the nth second, n minus 1 to n. But this AB, how can I write it? I can actually write AB as OA my OB. OB is bigger. So I can write it as OB minus OA. Yes, OB minus OA. Okay. Why? Because see, this much is AB. So this can be equal to from distance from here to here minus distance from here to here. Distance from here to here minus distance from here to here will give me this distance. Okay. Yes. OB minus OA. So what is AB? AB as a whole is S nth. Okay. So S nth. Okay, I'll write it here. S nth is equal to Sn minus 1. So that is the distance, Sn minus 1. Okay. So now we just have to substitute. What is the formula for displacement? ut plus half at square. So here time is n. So I take it as n. Displacement is ut plus half at square. Now if the time is t, it is ut plus half at square. If the time is 5, it is u5 plus half 5 square. If the time is n, then it is un plus half a n square minus. Now the time is n minus 1. So it is un minus 1 plus half n a into n minus 1 the whole square. Okay? Yes. Now I will just open the brackets. So when I open the brackets, what all will I get? Un plus half a n square minus un minus plus u minus half a n square plus a n minus half a. See, n minus 1 the whole square, n square plus 1 minus 2n. And then you have to multiply it with half a. Some of you might not have got it because I've just done it. So I want you to, after I finish the class, watch the recording. You solve it. You will definitely get it. You are a smart champion. Yes. So all the unwanted terms cancel. Half, u is there. An minus half a is there. Okay, let's write down these terms here and continue. Okay, so many messages are coming in the chat. I will respond to them. 1 second, let me not break the flow of the derivation. So, yeah, S nth is equal to u plus an minus half a. Now what I will do, I will just multiply and divide 2 here, just like I did in the previous case. So this will become S is equal to U, U plus 2 by 2 an minus half a. So from what I can do is here, I can take U plus half a outside. Okay. So I'll take half a outside. What remains? 2n minus 1 remains. So this is the equation for nth distance traveled in n second. Let me take a box. Pink box. No, I'll take a violet box. Okay. Yes. Okay. So this is the derivation for distance traveled in nth second. Okay, Sharp Gaming is doing MBBS now. Wow, congratulations, Sharp Gaming. So I have a personal doctor now. Okay? Yes. Very good, very good. All of you put some clap emojis for Sharp Gaming who's doing MBBS now. Ashwin, I'm not from Karnataka, but now I live in Karnataka. Okay? Yeah. But I was born and brought up in Kerala, but right now I have been living here for like few years. Okay, is that it? Anybody else? Any doubts? Hi, Monster Gang. Okay, all of you quickly share this to your friends. I want you all to come and text me after you share it to your friends, and your friends should say hi to me. Quickly, quickly, quickly. Let's have more people in the class. So, students, we derived all 4 equations of motions by using a method which is called as the general method. Okay? 2, 3, 4. Yeah, all 4 by using the general method. Now we'll just do a quick question and then we'll move on to the next method. We will do graphical method also today itself. Yes, in last class somebody was asking me, ma'am, will you do graphs today? I will do graphs today. Yeah, all of you. I want you all to send this to all your friends who are doing first PU. Tell them to join an amazing session. Don't you think it's amazing? Yeah? Okay? Let me put a line. Yeah. The art of drawing neatly, I'm trying to. Hi, Bhagavant. Yeah, I think it was. Okay. So let's look at this question. So this is A, this is B, this is C, this is D, this is the center O. A particle moves along a circular path of radius R. So this radius is R. Okay. This is a circular path. Okay. So there's a circular path and circular path has a radius R. Okay. So the path starts from point A. It moves anti-clockwise. So it moves in this direction. It moves anti-clockwise. Okay. So this is the radius R. So A is the starting point. From A it moves anti-clockwise. Alright. Find the distance traveled by the particle as it moves from A to B. Okay. I have to find the distance as the particle moves from A to B. So let's solve that. So particle moves from A to B. So when the particle moves from A to B, it's actually traveling 1/4 of a big circle, isn't it? I should have a ball here because in all the classes I have some reference with circles. Okay, anyways, if this is a circle, okay, I divide the circle into 2, it becomes 2 halves. If I divide the circle into 4, it becomes 4 halves. So A to B is basically 1 by 4th of the full circle. Yes, the circumference of the full circle is the total distance the body moves. So total distance is 2 pi r. So this much will be 1 by 4 into 2 pi r. Do you agree with me? 1 by 4 into the circumference of the circle, which is 2 pi r. So 4 and 2 will cancel. This is pi r by 2. Okay? Done? Clear? Next, from A to C. From A, okay, from A all the way till B is 1 by 4. Till C is how much? It's half of the circle. So, from A to C is half of the circle. So, half into 2 pi r, which is pi r. Next, third question. Yes, very good, Lava. Very good. It's pi r. Third question is from A to D. Okay. From A all the way till D. D is here. So this is how many? 1 by 4, 1 by 4, 1 by 4, which is 3 by 4. A to D is 3 by 4, 2 pi r, which is 3 by 2 pi r. Okay. Next, from when it completes one full revolution. When it completes one full revolution means from A all the way till A, which is equal to circumference of the circle. Full revolution is equal to circumference of the circle, which is 2 pi r. Easy peasy. Yes. Yes. Very good, Lava. It is 2 pi r. Very good. Very good. Good, good. Now there is a B part. This is all A. What is the B part? B part is find the magnitude of the displacement in each of the above cases. So I have to find out the displacement from A to B, A to C, A to D, and from A. Okay. So from A to B, will the displacement be same as the circumference? Yeah. Will the displacement be same as the circumference? No. Displacement is the shortest possible distance from A to B. So isn't this the shortest possible distance from A to B? Tell me. Yes? Okay. So A to B, this is the displacement. Now, if this is R and this is R, what will AB be? What will AB be? So let me write that. I'll just write that here. Okay. AB will be square root of R square plus R square, which is square root of 2R square, which is R square root of 2. Okay. Next, I have to find out the displacement from A to C. So A to C again. From A to C, the distance is this, but displacement is the shortest possible path. So this is the displacement from A to C is this. Displacement from A to D is what? It is this. Okay. Now I can leave my scale. Yeah. Okay. So let's do that. Displacement from A to C is, it's just 2 times the radius. So it is R plus R, which is 2R. Now displacement from A to D, again it will be the same thing. R square root of 2. R square plus R square, right? Okay, I will write the steps for those of you who have doubts. AD. AD will be square root of OA square plus OD square, which is square root of R square plus R square, which is R square root of 2. Or you can simply write it as R square root of 2 because you already know AB is R square root of 2. Next is the displacement for one complete revolution. How much will that be? For one complete revolution, how much would the displacement be? Yes, it will be 0 because it starts from A, it ends at A. What is the shortest possible distance? 0. Displacement, 0. Okay. Yes. So this is our question. Yes. Is this clear to all of you? If it's clear, quickly let me know in the chats. Put some thumbs up. Or put some fire. It's been a long time since you're not putting fire emojis now. Put fire emojis. Quickly, all of you put fire emojis. Mm-hmm. Okay. Okay. Let's look at the next question. Car is moving along the x-axis. Okay, so there's a car here. Okay, I'll just draw a car here. This car is moving along this axis. It moves from point O to point P in 18 seconds. Okay, so there's a small typing mistake here. This is just O. This is O. This is P. Wherever there are 3 alphabets, it's just single alphabet. Q. Yeah, you just have to understand it that way. Wherever it's a single 3 alphabets, it's a single alphabet. I think there's some typo. Okay? Yeah. So from O all the way till P, the car moves in 18 seconds. Okay? So from O all the way till P, the car moves in 18 seconds and returns from P to O in 6 seconds. Okay? O to P and then P to O. What are the average velocity and average speed for the car in going from O to P? Okay? So we have to find out the average speed. Average speed is what? Total distance by total time. Excuse me. Yeah. Okay. Average speed is total distance by total time. From O to P. What is the total distance? 360 meters. What is the total time? 18 seconds. So 360 by 18 is going to be 20. 20 meter per second. Okay. Now let's find out the average speed and average velocity also they have asked. Okay. Average velocity is total displacement by total time. It is total displacement by total time. So how much is it going to be? Same thing. What is the shortest possible distance from here to here? Same as distance. It's just so that it's just a question for you to understand the concept. Okay, you understand? So from O to P, he travels a distance of 360 meters. The displacement is also the same. So average speed and average velocity both are 20. Okay. Next. Question 2. What are the average speed and average velocity from O to P and then back to Q? Okay. O to P and then back to Q. Let's do that. Let's take a different color. I'll take green. Hmm. Average speed. Average speed from O to P, then P to Q. That's the question, right? O to P and then P to Q. So let's do that. So this is again total distance by total time. Total distance by total time. What is the total distance? O to P is 360 plus P to Q is 360 minus 240, 120. The total time O to P is 18 seconds plus P to Q is 6 seconds. So 360 plus 120 is 480. 480 divided by 24. 480 by 24. 20 meters per second. Next is average velocity. Average velocity. How do I find average velocity? It is total displacement by total time. Okay. Now what is the total displacement? So see, this is O, this is P, this is Q. So initially he moves, okay, I changed the order. This is Q, this is P. So initially he goes all the way till P and then he comes back to Q. So I have to find out the displacement. So displacement is my shortest path for me to reach Q. So what is the shortest path? Isn't it this much? Isn't this my displacement? Isn't that the shortest path? So total displacement will be O to Q is what? 240 divided by time will be all of the time. It will take 24. Time is going to be the same. Total time is not going to change. Divided by, so this is again 20 meters per second. Do you get the idea here? So this question is basically for you to understand the difference between distance and displacement. Okay. Yes. People are giving their Aadhaar card details also. How old they are, where they are from, their parents' name. I think I can start an Akshaya center here. I'll get all your details from the chat itself. Okay. Is that clear to all of you? Yes? No? Not interested? Okay. There's one more question here. This question I've already solved here, so this will be a homework for all of you. A body travels from point A to point B. Okay, this is point A. This is point B. Point A to point B at 60 meters per second and returns from B to A at a speed of 50 meters per second. Okay, so this way is 60, this way is 50. Alright, so body moves from A to B at 60 meters per second, from B to A at 50 meters per second. Calculate the average speed of the body and the average velocity of the body. Okay. Average speed and average velocity. A to B, 60, 50. So the steps are already given. I want you to do this as homework, but I'll just explain it. So total distance traveled is how much? If the distance to B is D, then the distance back is also D. Total distance is 2D. Yes. Now what is time? Time is distance by speed. So time is, in the first case, the time is going to be D by 60. Second case, the time is going to be D by 50. So total time will be D by 60 plus D by 50. Okay. So distance is D plus D, 2D. Now total time is distance into, you just do the math, you will get 11D by 300. I want you to all pause the video and quickly solve this. Yes. And find out the average speed, total distance by total time. Distance is 2d, total time is 11d by 300. Now, average velocity is what? Total displacement by total time. What is the displacement here? He starts from A, goes all the way till B, he comes back to A. So, obviously, his displacement will be 0. So, average velocity is going to be 0 because displacement by time. Displacement is 0. Okay. Okay. Sharmila has veg biryani at home today. Are you inviting all of us? Next is equations of motion under gravity. Okay. So we saw equations of motion general method. Now these are equations of motion under gravity. So what is under gravity? So imagine this is the earth. Okay. This is the earth and we are at there's a ball at a height h. Okay. So I'm standing on top of a building. I'm at a height h. I have a ball in my hand. So this ball initially is in my hand. So what happens? It'll have initial velocity 0. And then this ball starts to fall down. When it falls down, it is falling down only because of gravity. Isn't it? Is it falling down because someone is pushing it or pulling it or it has a motor? No, it is falling down only because of gravity. Yes, and the value of gravity. So the acceleration that it has. Okay, acceleration is what is pulling it down. The acceleration that it has is because of gravity. Now it is in the same direction of gravity, so it will be positive. And the value of gravity will be 9.8 meter per second square. Is this much clear? Now, if, let me take a different color. Okay. So if, okay, write it here. If acceleration is equal to gravity and the distance is or displacement both are equal to h, then what are the different equations of motion? Let us see. The first equation of motion is v is equal to u plus at. It becomes u plus gt. Second equation of motion, s is equal to ut plus half at square. Here s is h. So this becomes h is equal to ut plus half gt square. Next, v square is equal to u square plus 2gh. Okay. These are equations of motion under gravity. So some of you might ask me, ma'am, why do we use this? Why are so many equations there? Why is it so confusing? I'll explain it to you very clearly. Okay. See, if I'm driving a car, my acceleration is not because of gravity. It's because I'm accelerating on the car. So in that case, I will use my normal equation of motion. But if something is freely falling, like an apple falling down from a tree, or a ball falling down from the top of a building, or if I just drop this pen, oops, I actually dropped the pen. Sorry. Yeah. Okay. Things like that. If something freely falls, the fall is because of gravity. So in those cases, acceleration is because of gravity. Now imagine you get a question. A ball is dropped from the top of a building. Its initial velocity is this much, final velocity is this much. Find out the time or the height. But acceleration is not given. You should know if something freely falls, its acceleration is because of gravity. You should know that. Okay? Yes. Okay, now this is for a ball falling down. But what about a ball that I'm throwing up? In that case, what happens? So, same thing, I'll draw a graph. This is the earth, not a graph. This is the earth. This is a building. But right now, my ball is here. And it is going to be thrown up with a velocity of u. After some time it reaches the top, its final velocity is going to be 0. Okay, so now I am throwing it against gravity. So when I am throwing it against gravity, shouldn't my acceleration be minus g? Because gravity is something that is acting onto the earth downward, but now it's going up, so it should be minus g. So the value should also be, acceleration or gravity should be minus 9.8 meter per second square. Okay. Now let's write out the equations of motion for this. So here what happens? Acceleration is minus g, displacement is h. So what is the first equation of motion? V is equal to u minus gt. H is equal to ut minus half gt square. Next, v square is equal to u square minus 2gh. Do you understand this? So these are the equations of motion when something is pushed up. So if I'm throwing my pen up, then the equations of motion that it will have are these. Now if it is falling down, then the equations of motion will be these. Okay. Is this clear? Yes, lava has been giving me answers. Very good, lava. Okay, quickly write this down, all of you. Okay. What is 100 crore and all? Uday is talking about a lot of money in the chat. Sharmila, are you doing physics homework question? Okay. Is this clear to all of you? Yes. No. Okay. Now let's do a question based on this. Some of you might be wondering, why are these equations there? For that, to tell you why it's there, I'm giving you an example question. A ball is thrown upward with a speed of 20 meters per second from the top of a tower and it returns to the ground in 5 seconds. Find the height of the tower. Okay. So there's a ball. Okay. This ball is thrown up with a speed of 20 meters per second and it comes down with time 5 seconds. Okay. Oh my God, the chat is, yeah. Okay. So the time of ascent and the time of descent from the top of and returns to the ground, both together is 5 seconds. Okay. Yeah. So up plus down takes 5 seconds. So the time of moving up and the time of coming down both together takes 5 seconds. So up or down, it will be 2.5 seconds each. Okay. So time is going to be and returns to the ground in 5 seconds. Okay. Okay. No, this is just total time, right? A stone is thrown upwards with a speed of 20 from the top of the tower and returns to the ground in 5 seconds. So I don't think it's the total time. It's what I did in the first case. It comes down in 5 seconds. Okay. Yeah, it comes down in 5 seconds. So now initial velocity u is 20, time is 5. Here gravity should be plus or minus 10. Should be plus 10, right? Okay. And the formula that you should use is, you have to find displacement. So S is equal to, Should you use ut plus half at square? But a is not given. So here you should know that the ball is freely coming down. So when it's freely falling, its acceleration value should be g. Now here what happens? You have to find out the height of the tower when it is thrown upwards. So when it is thrown upwards, it's against gravity. So this is minus. So this is going to be ut plus half minus g into t square, or ut minus half gt square. If you just substitute the values, you'll get the answer. Okay. So the only things that you need to remember here, a ball is thrown up, so it's going against gravity. So the equation of motion is S or H, whatever alphabet you want, you can use. Okay. ut minus half gt square. Why minus? Because you're throwing the ball up. Okay. So it comes up and, both up and down, both are 5 seconds. So it goes up in 5 seconds, it comes down in 5 seconds. Okay. This is done. Yeah. Here I've just given you a small explanation for those of you who want on why G is negative. Okay. So here on why G is negative. Okay. So you can look at this. So when there is something is thrown upwards, it is positive. Yeah, when something is thrown upwards, the velocity is positive, but gravity is negative. Okay, this is the same thing that I explained already. I just wanted you to see the whole screen, so I moved out. Okay, so upward direction is positive, downward is negative. Okay. Okay, let's look at another question. Should I give this question also as homework? I have the answer here. Okay, I'll just solve it. A ball is thrown upward and is caught by a thrower in after 4 seconds. So a ball is thrown up and then it is caught after 4 seconds. With what initial velocity was it thrown? How high did it go? How far was it below the highest point? 3 seconds after it was thrown. Okay. A ball is thrown upwards and caught by a thrower after 4 seconds. So let's say the time of ascent, or the time when the ball was thrown up, is equal to the time of descent, and that is going to be equal to 4 by 2, which is 2 seconds. Okay, because he threw the ball and the other person caught the ball, and this whole process took 4 seconds. So which means it took 2 seconds for the ball to go and 2 seconds for him to catch it. Okay, so let's first do initial velocity. So I will take the equation v square is equal to u square minus 2gh. Why minus? Because I'm throwing the ball up. I already explained this. Now some of you might be wondering, why did I use this equation of motion? Because time is not given to me. Okay, h is not given to me. Is h given? H is not given to me. Time is given to me. Okay, let's see. Let's just do it. So v square is equal to u square minus 2gh. So at the end, the ball is caught. So at the end, the velocity is 0. So 0 is equal to u square minus 2gh. So now I have u square is equal to 2gh. Now I already know from my first equation of motion, v is equal to u minus gt. Yes. So 0 is equal to u minus gravity. I take it as 10 because it's easier to do calculations with 10. 10 into 2. So from this I will get u is equal to 20 meters per second. So it was good to use the second formula. Okay. So it's all trial and error. Okay. Now let's continue. We have to find out h. So that's how the next part comes into picture. Now from equation 1, this is equation 1. Okay. So from equation 1, 0 is equal to, what is u? 20. 20 square minus 2 into 10 into h, I don't know, I have to find out. So this is 20h is equal to 400. H is equal to 400 by 2, which is 20 meters. Now I have my height. Now C is how far did it go? So how far did it go is displacement. So S is equal to ut plus half at square. So this is u is 0 plus half. Acceleration is again 0. Why am I not taking g? How far was it below the highest point? 3 seconds after it was thrown. Okay. So into half into, okay, let's continue. S is equal to ut plus half at square. U is 0. Velocity is 0 plus half into acceleration g itself, 10 into 2 square or 3 square or 1 square. It's 1 square, no? Yeah. So you have to find out how far it was after 3 seconds. The total is 4 seconds. After 3 seconds, how many more seconds is left? 1 second. You understand? I throw the ball, it's at 3 seconds. The maximum it goes is still 4 seconds. So I have to find out the distance here. So this is 1 second. Okay. So this is 10. Hey. My board is not working. Come on. Try something else. Okay, it's just the eraser that's not working. Anyway, it is 10 into 1 square. So 10 by 2, the answer will be 5. We try a different eraser. Hey. What is this? Ma'am, you will teach in college. Yeah, I will teach. I can teach in college. Ashwin will join. Okay. First, let me see if students will watch my class in school, okay, like in YouTube. Then I'll decide if I should join in college. So it's all of your responsibility. If you want the channel to continue, if you want the lectures to continue, you have to keep supporting us. Yeah. And to keep supporting us, the only thing that you have to do is send this to your friends, ask them to watch it, like the videos, subscribe to the channel. That's all. Nothing else. Okay? So that is this section. Okay, I'm not able to erase that. I don't know why. Am I able to erase? Okay, I'm only not. Okay, now I am. Okay. Yeah. So that is the question. We'll just move so you can see what's written. Yeah. Okay. I think you were able to see. That's all. Yeah. Next is graphs. So should I do graphs today or tomorrow? Because graphs will take some time. Okay, let me just do it today itself. Some of you are praying, no? Ma'am, please tomorrow. Yes, Ashwin, very good. Send it to all your friends and tell them to subscribe to the channel. Okay? I want all your friends to click on the live and subscribe to the channel. Yes? Let's see how many subscriptions we can get. As Vedantu Physics team, let's see how many subscriptions we can get. It's Chetan, Uday, Suneta, Sharmila, all of you, quickly send this to your friends. Ask them to subscribe to the channel. Yeah. Okay. Now we're going to look at graphs. Okay. First, we will look at some basic ideas on graph, and then we will derive equations of kinematics using graphs. Okay. Let's do that. So for every graph, it has to have an x-axis and a y-axis. Yes. Any graph you've seen in your whole life till now, it'll always have an x-axis and a y-axis. Okay. Now, on the x-axis, it'll always be the independent variable. Okay. On the x-axis, it'll always be the independent variable. On the y-axis, obviously, it will be the dependent variable. So, it will be the dependent variable. Okay. Now, this, if I draw a line like this, okay, if I draw a line like this, what does it mean? It means that y has the same value. So imagine y has a value of 5 here. Then throughout y has a value of 5. So this means that y is constant, but x is increasing. See, if x is about 2, 4, 6, 8, x is increasing. Okay? Okay? So that is the meaning of this graph. Okay, so if you have a graph which has a straight line, it means y is constant and x is increasing. Okay, now let's look at the next graph. Ma'am, you had dinner. No, I didn't have dinner. How can I have dinner? I was sitting in front of you, no? I'll have dinner after I teach all of you. Okay. Ashwin, class timings. Class timings, usually my class is at 8 o'clock every day. Saturday, Sundays, it will be a little more early. Okay. Not every Saturday, Sunday, but tomorrow I have the next session. I have it at 12. Tomorrow, 12 p.m. Last part of this chapter will be there. Okay. Yeah. So now if you want to know class timings, you just have to go to Vedantu Karnataka YouTube channel. There are so many options like videos, shorts. There's an option live. Click on live. You'll see all the classes that are scheduled. Okay. So on the scheduled class, beside it, time will be there. Usually my classes are all at 8 o'clock. Every day, 8 o'clock. But I have alternate days. Okay. First PU, second PU, first PU. I take it like that. So you will have your first PU classes on alternate days. Okay, so this is x-axis, y-axis. Now let me draw another x-axis and y-axis. Okay, this is x-axis, y-axis. Now, if this is a graph that goes like this, what does this mean? This means that both x and y are increasing. You can see it's a graph like that. Both x and y are increasing. Okay. Now let's draw the next graph. Next graph. Next graph, x and y. Now what I will do? I will draw a graph like this. What does this mean? This means you can see x is increasing. See, x values are increasing 2, 4, 6, 8. So x is increasing, but look at y values. It is decreasing, it's going down. So y is decreasing. Okay, x is increasing, y is decreasing. Next graph. So you need all these graphs. That's why I'm explaining these graphs to you. X-axis, y-axis. The graph is pink, like this. So this also means x and y both are increasing. X increases, y increases. But what is the difference between, the graph beside it and this graph? What is the difference between these two graphs? The difference is that Here, x is increasing, but y is increasing slowly. Okay, so this is increasing slowly. Okay. Generally, I've already solved some questions in class itself. Now, if you want me to solve more, you can just put a comment in the video, not on the live chat, in the video, under the video. So then I will, if there are a lot of requests, I will do problems. I will do problems. Okay, don't worry. We will do derivations of formulas also. I already derived equations of kinematics using general method in this video itself. If you've not watched it, you can watch the recording. Okay, this after the class. Using graph, we will do it now. The next graph is this graph. So here also, x is increasing, y is increasing. But you can see y is increasing very fast. Yes. So here, increasing fast. Y is increasing fast. Okay. Yes. These are different graphs that you need to know. Quickly take a screenshot or quickly, note it down in your book. And then we will learn about these graphs. Okay. Did you all note down the graphs? Yes. Graphs are done. Next, we will learn about the slope of graphs. Okay, this is not your small class, but all this you need. Okay, if you know these basics, you will thank me when we do the derivation. It will be very easy for you. Next is slope. What is slope? Slope is, if this is a graph and this is a line, how much of an angle it makes with the x-axis. That is the slope. Okay, and in fancy terms, you say it is the inclination of the line from the x-axis. Okay, the angle to the x-axis. Okay, let's write it down. So if this is the x-axis and this is the y-axis, and let's say this is a line and it makes an angle theta. Okay, so the angle theta gives you the slope. So how do I find theta? I take tan theta. So tan theta, so slope, it's also represented by the alphabet m, is equal to tan theta, which is equal to change in y-axis coordinates divided by change in x-axis. Okay, change in y-axis coordinates divided by change in x-axis. Now, what does change in y-axis mean? See, here what is, with respect to this point, I have a y value, let's say it is y2. Now, with respect to this point, I have another y value, this is y1. So, change in y, delta y is basically y2 minus y1. Any two random points you take, okay? Any two random y points you take, you subtract them, divided by same thing for x. So, whatever point you take on the y, same thing you should take for x. So, down you have, if that was y2, this will be x2 and this will be x1. Okay, so this coordinate is x2, y2. This coordinate is x1, y1. Okay, so y2 minus y1 by x2 minus x1 is called your slope. You understand that? So what is slope? Slope is the same as gradient. It is taking two random points on the graph. Okay, you subtract the two y coordinates divided by subtracting of x coordinates. Okay, but sometimes I've seen students make a mistake. Okay, so if they have a graph like this, they might have some points outside the graph. You can't take those points. You should take 2 points on the line. Okay, 2 points on the line, subtract y divided by x. Okay, Ashwin, I am taking classes every day. Don't worry, I'm going to cover every chapter. Are you in first PU, Ashwin? You have to be in first PU, right? Yeah. So for us to continue this, we need people. Okay, we need subscribers, we need viewers. Only then we can keep continuing this. Yes, because we are a huge team. So the only help that we want from you all is sending this to your friends, asking them to subscribe, asking them to watch, asking them to study. That's the only thing that we need. If we get that from you, we will take classes for every chapter, everything, whatever content you want, we will have it for you. Okay? Is that a deal? Yes. Janani, these graphs they won't ask. But they will ask you to find slope, especially in your PU board practicals. In all practicals, you need to find slope. So you need this formula. And for graphs, they will ask you to find out, different things from graph. For that, you need to know these basics. You will understand why I taught these basics when we look into graphs. Okay? Okay? Yeah. Now, I'll tell you a simple example on why you need all this. If you have a graph like this, okay? If you have a graph like this, and I have a straight line. So let's say my y-axis is velocity and my x-axis is time, okay? Now, what does the slope represent? The slope would represent change in velocity by change in time. Why? Because slope is what? Change in y-axis coordinates divided by change in x-axis coordinates. What is change in velocity by change in time? Acceleration. So this can be a question. They can give you a velocity time graph. They can ask you to find acceleration. So you should know that the slope of a velocity time graph gives acceleration. Is that clear, Janani? I can give you one more example. Let's take another graph. Okay, so for this graph, I will put displacement on the x-axis and time. And I draw a graph like this. So what will the slope represent? Slope would represent change in y-axis coordinates, which is displacement, divided by change in x-axis coordinates, which is time. Displacement time is velocity. You understand? So the slope of a displacement time graph gives you velocity. You understand that? So that is why slope is important. So it is because you know that slope is change in y by change in x, you are able to do this. You understand? But directly they will not ask you what is the derivation or formula for slope. Okay? But they will ask you questions like this. Yes. Next is area under the curve. Ashwin, if your father is asking for your phone, you can give it to him. Okay, this class will be recorded. You can go watch it when your father gives you his phone back. His phone back to you. Yeah? We will have another like 15 to 20 minutes because I have to explain all the graphs. I will derive the equation of kinematics using graphs. Okay? So, you can watch the recording. Don't worry. But please don't forget to share it with all your friends. Not this live. Send this live. Send tomorrow's live. It's already scheduled. Send it to all your friends. Tell them to watch it. Tell them to subscribe. Not just Ashwin, to everybody. Okay. Next is area under the curve. What is area under the curve? So let's say you have x-axis, you have y-axis. Okay. And I have this is my graph. Now, if I find out the area under this curve, it's basically a rectangle, right? If I find the area under the graph, I get some values. Now, I will give you examples, then you will understand this better. So, let's say I have velocity, I have time, okay? And velocity and time makes a graph like this. What happens when I find out the area under the graph? So, this is going to be the area under the graph. So, area under the graph is basically velocity into time. It's basically the area of a triangle. So it's half into base into height. Half I'm just ignoring it. So it's velocity into time. Velocity into time is what? Displacement. So for your exam, if you get a velocity time graph and they ask you to find out displacement, you should know if you find the area under the graph, you will get displacement. Okay? Yes. I will give you one more example. Let's say it could be any shape. Okay. For the next graph, I'll draw another shape. Let's say acceleration and time. This time I will draw a graph like this, any shape. So how will I find the area under this graph? It is this part. So area under this will be acceleration into time. So acceleration into time is what? Change in velocity. So if you have to find change in velocity from acceleration time graph, it is the area under the graph. See, acceleration is v minus u by t. So acceleration is change in velocity by time. Okay? Is this clear? So this is why area under the curve is important. Now coming to the very important part of today's class. Not everything was important, but this is why we learned all these graphs. Okay? It is to find out the equations of motion by graphical method. See, we found out equations of motion by general method. We found out using gravity. Now we are going to find out by graphical method. So first of all, I will draw the graph for you. The graph is here for you. But in case you're wondering what is happening here, I'll just draw it once. I'll just replicate it once for you. So first thing, you have to draw the axis. Okay? So you have to draw the axis. So on the y-axis, you will draw velocity. On the x-axis, you will draw time. Okay? Is that much clear? Y-axis velocity, x-axis time. Now, you will take a body that is going to start moving from a point A. Okay? So this is O. So let's say somebody starts moving from point A and they move all the way till point B. Okay? Now at point A, they are at rest. So initial velocity is u. At point B, now what, I will just make this a triangle. Okay? Make this a triangle. So at point B, the final velocity is v. Now this part is what? This part is v minus u. Okay? That's all. That's the basics that you need to have. So here you have velocity, time. From here it starts all the way till B. This full thing is v, but this part is v minus u. Okay? I hope this is clear to you. Now if you didn't still get it, you can watch the video slowly. You will definitely get it. Okay? Okay. Let's now find out the first equation of motion. For that, what we will do, we will take the slope of the graph. Okay, so now you know why I taught you slope. So I will take the slope of the velocity time graph. And I already taught you slope of a velocity time graph will give you acceleration. Yes. So slope of the velocity time graph will give you acceleration. So acceleration is A. Acceleration A is equal to slope of AB. What is the slope of AB? Slope of AB is, if I take B and A as my two coordinates, it will be BC divided by AC. Okay? So that is also another formula for slope. Okay? So another formula for slope is AB is equal to BC by AC. Now if you have a line like this and you want to find out the slope of these 2 points, you make a triangle. Okay? And if this is A and B, what you do is you take this as C, and if you do BC by AC, you will still get slope. Okay? That is another formula for slope. So I'm going to use that formula here. So slope of AB is BC by AC. So what is BC? BC is V minus U. AC is how much? It is T, right? Yes, that has to be represented here. AC is T. So now I cross multiply this. So you will get AT is equal to V minus U. AT plus u is equal to v. Let me beautify all this. Let me erase all the unwanted stuff. This is T. Okay. So this is the first equation of motion using graphical method. V is equal to u plus 8. Is this clear to all of you? Yes, very easy. The only thing is I did find out the slope of the graph. Now, for the second equation of motion, again we will use the same graph. But this time, what I will do is, I will divide it into 2. Okay? I'll take this part in one color and this part in another color. Okay? Now let's do it. So I'm going to find out the area under the VT graph. So last time I found out slope. This time I'm going to find out area. Okay. So for second equation of kinematic, you need area under VT graph. Now to find area under VT graph, you have, if you find area under VT graph, you will get displacement. This also I explained. So since it's displacement, it is S. So S is equal to, what is the VT graph? I can divide it into a triangle and a rectangle. So what is the area of the triangle? Half into, what is the base of the triangle? AC into, the height is BC, plus area of square, area of rectangle is OD into the height, which is OA. Okay, so let's substitute everything. Half AC is how much? AC is just T into BC is V minus U. BC is V minus U plus OD is T, OA is U. Okay, so this is half T V minus U plus UT. Okay, so this is half into UT, half UT. Now what I can do is, I can write V minus U as 80. Can't I write that? V minus U is 80 from the previous one. Only then I get U plus 80, right? So V minus U, I will write it as 80 plus UT. So this becomes half AT square plus UT. So now the formula is S is equal to UT plus half AT square. Is this also clear to all of you? Okay. Yes. Parshu, I already take classes from second PUC. Please go to the channel, go to Vedantu Karnataka channel, check for the videos. Okay, I've already finished the first chapter almost for second PUC. Okay. Yes. Now last one. Okay. Last one. One more. Last one. We will stop with this for today. Okay, this is too much content for one day, no? I know. Your little brains might have started, oh God, my battery is running low. Just a second, students. I'm really sorry for that. Really, really, really sorry. Please. Yeah. Really sorry. Okay. So now what I'm going to do is for the third equation of motion, I'm going to put this whole thing as a one block. Okay. Now here, what I'm going to do is I'm going to find the area under the VT graph fully. I'm not going to break it into two. I'm going to find it fully. Okay. So again, area under VT graph is going to give me displacement. Yes, it is going to give me displacement. So S is equal to, I'm going to take it as a, what is this structure like a roof and a house? It's called a trapezoid. So it's going to be equal to area of trapezoid AB A OABD. I'll take it like that. OABD. Okay. Now this is going to be equal to that formula I've given here. For those of you who don't know, the area of a trapezium or a trapezoid is half times A plus B into H. Okay. So if this is the trapezoid, A and B are, okay, let me just draw it just like this. It's correct, no? Yeah. A and B are the parallel sides. Okay. So this is A, this is B. A and B are the parallel sides. And this is H. H is the distance between the parallel sides. Alright. Yeah. Now let's go back to our derivation. So S is equal to half OA. The first parallel side is OA plus the second parallel side is BD into the distance between the two, which is AC. Now simple substitution. What is OA? U plus V is OA. Okay. Am I still live? Something happened to my system? Okay, nothing happened. Okay. OA is U. BD is V. So together this is U plus V. AC is T. Yes. So now this is if I multiply 2 here, I'll write the rest here. So 2S will be U plus V into T. So 2S will be U plus V into what is the time? Time is V minus U by A. Yes, A is equal to V minus U by T. So T is equal to V minus U by A. I hope you know how I get this. Yes, first equation of motion. A is equal to V minus U by T. I just cross multiply A and T. So now what I will do is, I will multiply. U plus V into V minus U is what? A plus B into A minus B. So that can be written as A square minus U square. Okay? Divided by A. So now multiplying 2AS is equal to V square minus U square. So from this you get the formula V square is equal to U square plus 2AS. Now to avoid some confusions here, this is V minus U. Here I will just write it as sometimes you might get confused. Now here I'll write it as U plus V. Here I'm going to just change the order. Okay. So now I have the equation. V square is equal to U square plus 2AS. This is the third equation of motion. Okay. Yes. So I think we should wind up with that, okay? Because it's already a lot of time. So we have derived we've derived all the three equations of motion using graphs, okay? Equation 1, equation 2, and equation 3. How did we do equation 1? Equation 1 was by using the slope of the VT graph. Equation 2 was by using the area under the VT graph. Now equation 3 is by using the area under the VT graph, but this time I'm not going to break it into a triangle and a rectangle. I am going to use it as a trapezoid or a trapezium. Understood? So we have derived equations of motion using general method. We have derived it using gravity. We've also derived it using graphical method. Okay? Is this clear to all of you? Yes. So we will continue tomorrow. Okay? So if you're watching the recorded class, you have to go to part 3 next. This is part 2. Part 1 is already done. So this part 1, part 2 and part 3. Yes? So I'll see you tomorrow. Yes? Okay? Please, students, please let me know how the class was in the comments. Okay? Because I take a lot of time and effort to do it. And it's just for all of you. I want all of you to understand and learn physics, because if you understand and learn physics, physics is beautiful. Yes? So please do like the video, share it to all your friends. Let them also learn from the best. Subscribe to the channel so you keep getting updates on new classes and all of that. So if you are someone who's enrolled for first PU or CBSE or second PU, anywhere, we are here to help you. Okay? Yes? Yes. So good night. If you're watching live, others, whatever time of day it is, I hope you enjoyed the session. Please do let me know in the comments. I'll be very happy to read them. Okay? I'll see you tomorrow with another wonderful session.